whoops, we need to get that to focus better. Okay, so to understand how to do partial fractions, you need to understand how to add fractions, or you need to remember how to add fractions. If I want to add these two things together, I need to get common denominators. So I need to multiply this by x minus 2 on top and bottom, and I need to multiply this one by x plus 5 on top and bottom. So then my numerator will be 3x minus 6 plus 8x plus 40 over x minus 2 times x plus 5. If we combine like terms, 8 plus 3 is 11, so we have 11x. 40 minus 6 is 34 over x minus 2 times x plus 5. Okay? Today, we are going to start with this, start with the answer, and go back to the original problem. I'm going to give you a problem, and then you're going to tell me what fractions it came from.
How did you end up with x minus 2 and x plus 5?
Yeah, if I take the denominators times each other.
Oh, because common, okay.
Yeah, got to get common denominators. Okay, so any questions on that? Okay, so let me show you how you go backwards. So example 1. So let's say you have x minus 3 over x squared minus 2x minus 15. The first thing you need to do is factor. So that would factor into x minus 5 and x plus 3, because I need two things that multiply to 15 and add to negative 2. Okay? Now, we're going to try to figure out the a that came from the fraction over x minus 5 plus the b over the fraction that came, or the number that came from the fraction b over x plus 3. Okay? So, ignore this now, because that was just where we started, and we had to factor it. So we are going to now multiply everything by this denominator. We're actually going to get rid of our fractions, okay? We're going to multiply everything by x minus 5 and x plus 3. So we're going to multiply this by x minus 5 and x plus 3. And remember that this is over 1. Okay? Now we do that so that this x minus 5 cancels with this x minus 5, and this x plus 3 cancels with that x plus 3. So this cancels over here too. So I got to take both sides of it. I usually don't write this step out when I'm doing it, because that whole denominator is going to cancel with that. So my new equation is x minus 3 equals ax plus 3a plus bx minus 5b. Okay, and everybody take a look at that. Do you see where everything came from? Okay, so now we're going to sort it. We're going to make different equations of this. We're going to make like a system of equations. We're going to take everything that doesn't have an x in it, and then we're going to take everything that does has an x in it and make an equation. So this one equation is going to become negative 3 equals 3a minus 5b, and x equals ax plus bx. So look at that and see if you see where that comes from. Like if I was going to combine like terms, you know, up here on the example that we did, the 11x came from putting 3x plus 8x together. Okay, so this 1x has got to come from adding the ax plus bx together. So that's where I get that equation. Do you guys see that logic? If the a and b were numbers, because they are, we're trying to find what number a and what number b are, okay? Whatever numbers they are, don't they have to add up to 1? Because if you combine like terms over here, you get ax plus bx, or a plus b times x. So doesn't a plus b have to equal 1? If I get rid of the x's, doesn't 1 have to equal a plus b? Maybe you kind of see that, maybe you're not totally convinced yet. Let's talk about the coefficients. Not the coefficients, the constant. Let me get a different color here. You've got a -3 here. Doesn't that have to come from adding the constants on the one side together? Like the 3a doesn't have an x in it, and the -5b doesn't have an x in it. Whatever those numbers are, if they don't have an x in it, I'll be able to combine them together, and then doesn't that have to give me -3? Okay, so that gives me two equations. It gives me -3 equals 3a minus 5b, and then when I get rid of the x's, it gives me this, so I have 1 equals a plus b. I have two equations because I have one equation for my x values and one equation for my constant values. Now I have a simple equation that I can solve. I'm going to multiply that one by 5, so that will give me 5 equals 5a plus 5b, and my top equation stays -3 equals 3a minus 5b.
Wait, why does,
Go ahead.
where that 1 equal a plus b?
Because I have one x over here, and that equals ax plus bx. So if I divide that equation by x, I get 1 equals a plus b.
Can you just say like you factored a x out?
Yes, yes, yeah. If that makes more sense to you guys, I could think of it as factoring. X is equal to x times a plus b, and then if you divide both sides by x, you get 1 equals a plus b.
So, you multiplied both equations by 5?
No, I multiplied the bottom equation by 5 because I have a -5b there, and I want to get my b's. Now my b's will cancel, and I get 2 equals 8a. -3 plus 5 is 2, and 3a plus 5a is 8a. So if I divide both sides by 8, then 1/4 equals a.
I'm not lost. I only have my one equation.
So do you have -3 equals 3a minus 5b somewhere?
I have -3 equals ax plus bx. And I have,
Oh, you've got it mixed up then. If you have -3 equals ax plus bx, you're mixing your constant with your letters. So if you look back at this original equation, you want to put the blue is the stuff with the x's, and the orange is the stuff without the x's.
so it should be -3 equals 3a
Uh.
plus 5b.
Minus 5b, because it's minus 5b. And then from the x's, you get 1 equals a plus b. Other questions on this, guys, before I go on to the next step? We'll do more, okay? So you get a chance to understand it. Okay, so if a is 1/4, I'm going to go back up here to this equation. I can plug it in anywhere and try to solve, but that would be the simplest. 1 will equal 1/4 plus b, so 1 minus 1/4 is 3/4. So that's my answer for b. Now, what the heck does that mean? Back up here, this is how we started. A over x minus 5 plus b over x plus 3. Well, we found that a is 1/4, so that means 1 over 4 times x minus 5, and I'll write this out a different way if it makes more sense to you, plus 3 over 4x plus 3 would equal our original x minus 3 over x squared minus 2x minus 15. If you want to have the 4 up on top, you could say 1/4 over x minus 5 plus 3/4 over x plus 3. And then that equals our original problem, x minus 3 over x squared minus 2x minus 15. So we found the numbers that would go in these fractions so that when we added them together, we would get x minus 3 on top.
Where do you get x minus
That was the original problem. The original problem is find the numbers so that they add up to x minus 3 over x squared minus 2x minus 15. Uh-huh.
So basically, if you find the A or B first, and you just find one, you can just subtract that from one, whatever you get.
Only in this case it was equal to 1. If this would have been a 7x, then you'd subtract it from 7. But yeah, you'll plug it back up into one of your simple equations to get it.
Okay.
Now the problem is this is just an a and a b. If we have an x squared, then we're going to have an a, a b, and a c. Okay, ready for the next example?